So in the introduction video for this area under graph, I talk about addition and subtraction of area. So if you already can identify positive area and negative area, the next thing will be you identify when I'm going to add the area, when I'm going to subtract the area. So if you see in this case, right, the area that I'm interested in is hanging in the air. Can you see it's kind of like hanging in the air, floating in the air. So this kind of area is usually a subtraction. So because it's floating in the air, okay, if you still remember, I mentioned you got to dot down the intersection. Because if you don't dot down the intersection, you cannot create the vertical wall. So if you don't have the instinct to dot down, you cannot create the wall, and subsequently you cannot create your definite integral so that you can do your area under graph. Okay, so in this question, finding the coordinate of P and Q is purely through simultaneous equation. So P and Q are the intersection. So no trick about it. Just perform your simultaneous with no calculus, and you will get the rightful coordinates. Okay, so I perform my simultaneous. Okay, and I get their coordinates. Okay, this is no trick. Okay, subsequently, the x coordinate created the wall already. So if you still remember the subtraction, so I should be using this one. I should be using under the straight line. So under the straight line and the two wall, remember definite integral will always calculate the area that is connected to x-axis. That means the area will stick to the x-axis. So actually, if you take a look, right, this is like a trapezium. So you can do the trapezium. So I am doing the trapezium. So I'm using the trapezium. So if I'm doing the trapezium, this is the H. That's why it's 6 units. This is the parallel length. So the parallel length came from the y coordinate. So this is 3 units tall and this is 6 units tall. So I'm using the trapezium formula. Alternatively, you can also do it like area under graph. You got the straight line equation. So you integrate the straight line within the two wall, 4 minus 2. You try doing that, you will get the same answer. So it's your own preference. If you got a geometrical shape like a trapezium and you got the coordinates, would you like to do it through the geometrical formula or would you like to do it through definite integral? Both are okay. You will not get different answer unless you're careless. So here I got a trapezium and I am going to subtract under the curve. I'm going to subtract under the curve, but also within the same wall. So I'm also going to subtract under the curve, but within the same wall. So I will be using the curve equation. So that's why you see I use the curve equation. So a curve doesn't form a geometrical shape, so I got no choice. I can only do it by the definite integral. So you make sure you integrate first. Then after that, you do the top minus bottom. So this is the top value, and then this is the bottom value. So definite integral means you got to integrate first, then you sub in the top number to subtract the bottom number. So don't miss out on the integrate. Some people, they forgot to integrate. They will just directly put in the top number and the bottom number. So the blue one, you're getting an 18. So if you look, it does make sense. I'm expecting the under curve to be smaller than the trapezium. So it's quite obvious the trapezium is bigger than the blue part. So if you want to get the shaded area, it's just a pure subtraction. So under such a situation, if you're doing subtraction of area, I wouldn't advise you to do a direct subtraction. So some people, they will do trapezium minus area under graph straight away. And if you're very subjected to careless mistake, you might not get your method marks. So it's advisable that you do area piece by piece. So one piece and one piece, whether you add up or you subtract. So this one will illustrate the idea of area under graph, but we are using a subtraction idea.